Greetings, Calculus Explorer. I want to talk with you today about a thing called the conjugate, a little ditty that you might have encountered when dealing with limits that are of indeterminate form. I'm talking about limits that look like the limit as x goes to 4 of x minus 4 over the square root of x minus 2, something like that. So this limit has indeterminate form, which we can see because when I try to evaluate this function, so I'm just going to plug in my x value of concern. I'm going to plug it in. I'm going to get 4 minus 4 over the square root of 4 minus 2, which is equal to 0 over 0, which is an indeterminate form. Okay, so plugging in didn't work. Substitution didn't work. The function isn't continuous, and substitution only works for continuous functions. So I've got to do something else to tackle this problem. Okay, so I see two distinct ways to solve this, and one of them is to multiply by this thing called the conjugate. Okay, we're focusing our attention in this on the denominator because it's got this square root on it, and the square root's like kind of troublesome as far as that goes. So what I'm going to do in order to solve this problem and move it forward is I'm going to multiply by the square root of x plus 2 over the square root of x plus 2. Let me throw some parentheses around this right here. This thing, a square root of x plus 2, is the conjugate of the square root of x minus 2. Let me write that down for you. The square root of x plus 2 is the conjugate of the square root of x minus 2. So the only thing that changed when going from here to here is that my minus sign turned into a plus. And similarly, it could be the case that I've got pluses that need to turn into minuses. So the square root of x minus 2 is the conjugate of the square root of x plus 2. So we're just changing the sign of the thing in the middle. That's what the conjugate is. The conjugate is the same term with a minus instead of a plus. Okay. So I want you to observe what the next step in this calculation would be when we're doing this limit with this indeterminate form, applying our algebraic techniques to solve it. The next step for me would be to leave the top alone. And the reason is that this right here is going to turn into x minus 4. So this is equal to the limit as x approaches 4 of x minus 4 times the square root of x plus 2 all over, let's see here, square root of x times the square root of x is the square root of x squared minus 2 times the square root of x plus 2 times the square root of x for the outsides, and then finally minus 2 squared. And then these two terms here are additive inverses of each other, and so they cancel, which means that I'm just left with the square root of x squared minus 2 squared. I'll move that 2 squared over also. So square root of x squared minus 2 squared. Okay. Which is x minus 4. So the square root of x squared is x. And 2 squared is 4. And then voila, they cancel. And I'm left with a 1 in the denominator and a square root of x plus 2 on the top. And then I can try substitution. So the multiply by the conjugate thing deals with this essentially a removable singularity or removable discontinuity in the function that you're doing the limit of. Okay. So let me approach the conjugate one more time as kind of an abstract thing without a connection to a particular problem, which means I'm going to use generic letters or placeholders instead of these specific things. And I think there's a lot of power in using the generic symbols, because then we don't get lost about like 2's and square roots, but you can see what the thing is truly in action. Okay, so given a term that looks like A minus B, the conjugate is A plus B. And if I start with a plus, then it turns into a minus. So A plus minus B, the conjugate is A minus plus B, which indicates that the SIGN sign is changing in the middle. That operation is turning from plus to minus or minus to plus when we do the conjugate. And the reason is that A squared minus B squared is what we call a perfect square. And it turns into, well, sorry, it easily factors. It's not a perfect square. It turns into A minus B times A plus B. Okay. So the fact that this thing factors like this into A minus B times A plus B is exactly what makes multiplying by the conjugate useful. So given one, we're going to multiply it by the other so that we get this thing right here. And that's going to make our life easier when we need to cancel. So what's the conjugate? The conjugate is the thing that you need to multiply a term by so that it turns into the difference of two squares, which is often very useful for getting a numerator or denominator to cancel to do away with an indeterminate form and let you attempt substitution after doing simplification on a limit. So thank you very much for watching, and good luck with your conjugates.